Just a couple more optimization problems for you before we finish up here, since most of the things in the homework problems were pretty similar. Let's go ahead and look at number 10 from the quick quiz following section 3.4. So it says the resident population P in thousands of West Virginia from the year 2000 through the year 2014 can be modeled by P is equal to negative 0.077 T cubed plus 1.47 T squared minus 2.3 T plus 1805, with T being between 0 and 14 years inclusive. T equals 0 represents the year 2000. Okay. So during which years was the population increasing or decreasing? So we can use the first derivative test for that. P prime is negative 0. Let's see, 14 and 14 and 1. Sorry, 3. So this is 21. Here, 0.077 times 3. I've got my calculator, so I need to go ahead and use it so I don't make an arithmetic mistake here. 0.231 T squared, and then 1.47 times 2 is 2.94 T minus 2.3. I need to figure out when that's equal to 0. I'm going to put that in y equals negative 0.231 x squared plus 2.94x minus 2.3, and zoom 6, and I'm going to come to the right a little bit, 0 to, let's say, 15. Here is my domain. So there we go. And I'm interested in second calc 0. Where does it cross the x-axis? Over here? And it crosses at critical numbers. T equals 0.8374118. Second calc 0, and we'll come over here on this side. $11.889861. And we can also see from our graph of our first derivative there that our first derivative test here, let's just call this C1 for critical number 1 and C2 for critical number 2, that I have the first derivative is negative, then positive, then negative, so it's decreasing. Then the function of P is decreasing, then increasing, then decreasing. So we have decreasing, increasing, decreasing like that. So there's going to be a local minimum here and a local max here. And I can go ahead and make my calculator remember that x value. I'll go ahead and work on this one that it knows it right now. So let's go ahead and tell it to know what negative 0.77x cubed plus 1.47x squared minus 2.3x plus 1805 is. I might be getting ahead of myself. What years is it increasing? When is it decreasing? So it is not quite a year that it switches from decreasing to increasing. So it is decreasing, say, from 2000 to roughly 2001, and then it's increasing roughly from 2001 to about year 12, so 2012, and then decreasing again roughly from 2012 to 2014, just roughly, since I have to probably give years that are in whole numbers there. And so that was part A. During which year from 2000 through 2014 was the population the greatest? It was the greatest right here at 20, let's see, that would be during the 12th year, so during 2012, because more than 11 years have passed. So during 2012 had the greatest population. It doesn't actually ask me what that greatest population was. I won't find it. And then when did it have the lowest population? That would be during the year 2000. So lowest population during the year 2000. It's decreasing, hits a low point, and then turns around and comes up for quite a long time, and then starts to decrease just a little bit at the end over there. So if we wanted to see what Y2 looked like on this interval here, and you might need to zoom out a little bit here. Okay, I might need to zoom out a lot. Okay, you can't really see it very well, but it's there. It does do this. So let's go ahead and move on to number 15 from this quick quiz and say by increasing the advertising cost X in thousands of dollars for a product, a company discovers that it can increase sales capital S in thousands of dollars according to the model. Let's see here, S of, got cut off on my paper, so I'm going to read it directly from the book here. S is 1 over 3,600 times 360 x squared minus x cubed. and that's between 0 and 240 inclusive. Remember that X is measured in thousands of dollars, so they're going to invest somewhere between 0 and $240,000 in advertising, hoping to get out S in sales. That's also in thousands of dollars here, and we want to figure out here, find the point of diminishing returns for this product. So that's going to require the second derivative. That's going to be 1 over 3,600 times 720x minus 3x squared. S double prime is 1 over 3,600 times 720 minus 6x is, I'm going to pull out a -6, is -1 over 600 x minus 120. So set that equal to 0, and x minus 120 equals 0, x equals 120, and plug that back into the original here. 1 over 3,600 times 360 times 120 squared minus 120 to the third is going to give us S of 120 is 960. So your point of diminishing returns will be 120, 960, which represents if 120,000 is invested in advertising, then the sales will be $960,000 in response to that. So again, less really about your optimization here, just more about a little bit of a review of some other things with the first derivative test or second derivative test, and the the first derivative test for increasing, decreasing functions, and your point of diminishing returns. So that's it for this video, and we'll come back next time to start talking about topics from 3.5, which are more business and economics applications in 3.5. So more of the same, a little different, more revenue, price, profit, cost, average cost, all those types of things. So we'll come back and do a little bit more of that next time. See you for the next video.